Today we're going to work on transformations. A transformation is a process of moving all the points of a geometric figure according to certain rules to create an image of the original figure. The original figure is called the pre-image, and the figure that results from a transformation is called an image. A transformation can also be defined as a function that takes points in the coordinate plane as inputs and gives other points as outputs. The points put in as the input would be represented from the pre-image, and then the outputs are the coordinates from the image. When performing a geometric transformation, you start with a pre-image, and then some type of transformation is applied, and it results in the image. There are several ways to notate transformations. One would be a mapping rule, which we usually see like with an arrow as shown from pre-image to image. We could talk about a figure. So if we start with our pre-image called figure A can be transformed into A prime. Whenever we have a pre-image that is transformed, we always denote the image with the little apostrophe, which is called prime. You can also use a mapping rule with coordinates. So if you have coordinates from the pre-image x, y, it can be mapped to the coordinates x prime, y prime. So that's called your mapping rule. You can also use a function rule to show transformation. And so that'll be f of x, y equals x prime, y prime. Notice that in this case you have two values going in as your inputs, and that's because we're dealing with coordinates. So just having x being the input wouldn't be enough because we're moving x and y coordinates. There are two main types of transformations, and those transformations are rigid or non-rigid transformations. Rigid transformations preserve the size and shape of the pre-image. Another name for rigid transformations is isometries. The singular form of the word isometries is isometry. Iso literally means equal. Metry means measure. So the word isometry literally means equal measure. Notice how that corresponds to the idea of the transformation being rigid and the definition being that it preserves size and shape of the pre-image, so it maintains the same measure. You can tell that a rigid transformation has been applied if the image is congruent to the pre-image. The symbol we use for congruent, just as a by the way, is this symbol. There are several properties that all isometries share. Isometries all preserve distance, angle measure, betweenness, and collinearity. There are three types of rigid transformations. These are reflections, rotations, and translations. Some common words we might associate with these types of isometries are flip for reflections. So we think about a figure being flipped over a line. Rotations is like turn. So we turn a figure about a certain point. And translations are like a slide. So it can be slid left, right, up, or down. Today we have learned that there are two main types of transformations: rigid transformations and non-rigid transformations. Non-rigid transformations do not preserve the size and shape of the pre-image. You can tell that a non-rigid transformation has been applied if one of three things happens. So if the size of the figure changes, then a non-rigid transformation has been applied. We can be more specific and say that a figure has been reduced, so the size has gotten smaller, or it has been enlarged, so the size has gotten bigger. We can also spot a non-rigid transformation if the shape of the figure changes. If both the size and shape change, that also tells us that a non-rigid transformation has been applied. There are three types of non-rigid transformations. You can see a vertical shrink, which can also be called a horizontal stretch. I think of the vertical shrink as pushing down on the figure so it's getting longer or fatter. You can also see a vertical stretch, which is also known as a horizontal shrink. I think of the vertical stretch as taking the figure on the top and the bottom and pulling it up and down, and so it's getting skinnier or taller. The final type of non-rigid transformation is a dilation, and these are pretty special. It can either be a reduction or an enlargement. So dilations make the figure either bigger or smaller, but it never changes the actual shape. Whereas the vertical shrink or the vertical stretch, they do change the shape of the figure. So dilations are really special because they create similar figures. We'll learn more about dilations in another lesson. Just like we talked about earlier that congruent has a special symbol, so does similar. So if you were to use a symbol to represent similar figures, it would just be this symbol. Now we will try a few example problems. Example 1 tells us to use the mapping rule that's given to plot the triangle's image. And then we have to figure out if the mapping rule is giving us a rigid or non-rigid transformation and explain why. So notice that the mapping rule is this statement right here. It's called a mapping rule because it literally tells us how to take these points from the pre-image, apply a transformation, and map it onto the new ones for the image. And so what we're seeing here is the mapping rule states that xy goes to x minus 4, y plus 3. So we know that for all of the points on the triangle, the pre-image, we're taking the coordinates, and for the x coordinates we subtract 4, and for the y coordinates we add 3. So in order to do this, we can find the coordinates of our pre-image and then apply this rule. Notice that I created a table just to help me organize my work. So I noticed from my graph that my pre-image coordinates A, B, and C are located at 0, 0, 2, 0, and 0, 4 respectively. So now I'm just going to take each one at a time using the mapping rule. So if I look at A, it's at 0, 0. And I know if I'm transforming that point, then I'm going to be left with A prime. So to find out what the coordinates of A prime are, I take my 0 and I subtract 4 from it, from over here, with this mapping rule. So I do x minus 4, so that's 0 minus 4, and that gives me negative 4. Then I do the same thing with the 0 for the y coordinate and apply it to the rule, right? So I have y plus 3, but my y value is 0, so 0 plus 3 is 3. So now I know that A, 0, 0 is mapped to A prime, negative 4, 3. So I can follow the same logic to figure out my coordinates for B prime and C prime. So B prime, I have 2 minus 4, which is negative 2, and 0 plus 3, which is 3. Finally, I have C prime, that's going to be at negative 4, 7. Now that I have my coordinates, I just need to plot them. I know that A prime is at negative 4, 3, B prime is located at negative 2, 3, and C prime is located at negative 4, 7. To finish, I just have to connect the dots in the same order that I saw them in the pre-image. So I have A prime to B prime to C prime, and C prime to A prime. So I've finished the problem halfway. I was able to use the mapping rule to plot the triangle's image, A prime, B prime, C prime, but now I had to figure out if this mapping rule gives me a rigid or non-rigid transformation. So notice that the figure I start with, my pre-image, and the figure I end with, the image, they have the same shape and the same size. Therefore, the mapping rule gives us a rigid transformation. This problem is asking us for the same steps as example 1, but we actually have a function rule instead of a mapping rule. So notice that down here we have a function rule, like we talked about earlier. So we have f of xy equals negative x, y. So we know that our input xy, once the transformation is applied, it gives us the coordinates negative x, y. So we also have the same exact pre-image as example 1, so we can use the same coordinates we found, and then we just use this new rule to determine what our image coordinates are going to be. Looking at the coordinate 0, 0 for A, I know that the coordinates for A prime are found by using the function rule right here that says negative x, y, right? So we're going to take our x value and find the opposite of it, but the opposite of 0 is still 0. And then we're going to keep the same y value, so that's still 0. For B prime, we have 2 for B for the x value, so now we have to do the opposite of that. So our x value for B prime is negative 2, and we keep the same y value. For C prime, the opposite of 0, well, that's still 0. And then y, we're keeping it the same, so it's 0, 4. So now we have our coordinates for our image. Like we did in example 1, all we do is plot these, connect the dots, and then we have plotted the triangle's image. So we'll just zoom in here and plot 0, 0 for A prime. And I know that we already have A in that same spot, so we really do put our point there. We just have to label it A prime, right? So it really is there. And we also know that B prime is located at negative 2, 0. So then we're going to plot negative 2, 0 and make sure we label B prime. C prime is actually in the same spot, as C is as well, so we can still plot that point and label it C prime. So now we just connect our dots, and now we have our image plotted on the graph. And so now we have to figure out if this is a rigid or non-rigid transformation. If you notice, it just looks like this was flipped. The pre-image was just flipped over to create our image. And so if it was just kind of flipped over, it didn't change size, it didn't change shape. So we know that if shape and size are maintained, it has to be a rigid transformation. If you notice, I said the word it was flipped over the y-axis. So actually this transformation is a reflection. For example 3, we're given the same instructions and we have a function rule, but this function rule is a little different than what we've seen before because now we're multiplying our x and y values. So if we look at A, if we multiply 0 by anything, we're still going to get 0, right? So A prime is still located at 0, 0. But for B prime, 2 times 2 is 4, so B prime is located at 4, 0. And C prime will be located at 0, 8. So we're going to go ahead and plot those. So as you can see, we've plotted our image now, and we can definitely tell this is not a rigid transformation because although the shape is maintained, it's a lot bigger, right? So because the size has been changed, we know it's going to be a non-rigid transformation. And fun fact, this is actually considered a dilation because we multiplied the x and y by the same scale factor. And if you can see that these really are similar figures. But we'll get more into that in a future lesson. Our last example goes back to another mapping rule. We know this is a mapping rule because we have xy goes to x 0.5y, right? And we have this little arrow. So this is what a mapping rule looks like. But we treat the function rule and the mapping rule like the same. It just depends on what they look like, right? So again, we have the same situation, the same coordinates. So we have to look at this mapping rule. And in this case, we're only multiplying the y value by 0.5, and we keep the x values. So A prime is going to be located, again, at 0, 0. Anytime you have 0, 0, if it's being multiplied, it is going to stay the same. B prime is going to be at 2, 0. And C prime is going to be located at 0, 2. So we're going to go ahead and plot those and get our lines up there. So notice that I have A prime, B prime, C prime plotted. And I'm just going to shade in a little bit blue so you can really see the difference here. So this, although this is a triangle, it's not the same triangle shape as before. So the shape has been changed, the size has been changed, so we know this is definitely a non-rigid transformation. We also know that this is not considered a dilation. So we have it plotted, and now we've seen an example of a non-rigid transformation. So the last part of this video is to do a quick check-in to see what you've learned and see what questions you have. So there's a Google form in your Google Drive folder for the check-in on transformations. And in that Google form, you're going to answer the following questions. Question 1. You need to determine whether the transformation that is shown between the pre-image and image appears to be rigid or non-rigid, and you'll have to explain. The second question is which of the following are rigid transformations? Select all that apply. So this concludes our overview on transformations. Here we don't have any learning targets because we're really just laying the foundation for the rest of the unit. Here are the credits for the people who let us get these awesome resources for free. Check them out, and thank you so much for watching.